Welcome to September 15th LeetCode Challenge, longest turbulent subarray. Given an integer array, return the length of the maximum size of the turbulent array. A subarray is turbulent if the comparison sign flips between each adjacent pair elements in the subarray. More formally, the subarray A at index I, index plus 1, at index j of AR is said to be turbulent if and only if for each I strictly less than or equal to k less than j, where the element of the index of k of the array is greater than the element of k plus 1, where k is odd, and the index of k of the subarray is less than k plus 1 if k is even. Or in other words, vice versa, if I is strictly less than or equal to k and less than j, such that the index k of the subarray is greater than the index of k plus 1 when k is even, and when index of k of the array is less than the k plus 1 and k is odd. So all of this formal definition here and turbulency of the subarray just means that basically if you go from array 1 to array I to array I plus 1, you get. I'll go through the example here. So basically, we want to find the largest subarray that's turbulent the longest. So let's say here we have the array 9. This array here, we have 9 goes down to 2, so we have a negative comparison, right? Because 4 is less than 9. I'll just copy this actually. So 9 is greater than 4. But then we have the next one after this. If we're comparing 4 to 2, 4 is greater than 2. So obviously we have a slope, right? So 9 is greater than 4, which is greater than 2. So that won't work. However, let's start at 4 now. We have 4 greater than 2, and 2 is less than 10. 10 is greater than 7. 7 is less than 8. Right, and then we have 8 being equal to 8, which doesn't work, right, because it's not turbulent. So we see how there's a turbulency here, so we basically have going back and forth in terms of sign comparison, so we have greater than, less than, greater than, less than. So that's kind of what we want, and if we have add all this up, we have basically 4, 2, 10, 7, and 8. That's the longest length of the subarray that will give us a turbulent array, which is going to be 5, right? And the count of that's going to be 5. We return the output of 5. It even explains it here. So subarray of index 1 is greater than index 2, which is less than index 3, which is greater than index 4, which is less than index 5. So that's pretty much the idea. And so given here, we have basically the array if we have an increasing array, the max we can return is 2, right? Because it's always increasing, so we have basically 2. If the array has the 1 number in it, obviously the output is going to be 1. Our constraints is the rate of length number, the rate of index, okay. So intuitively, we can see that we only care about the comparison between two adjacent elements. So the comparison between two numbers could be, obviously, as we've seen before, it could be of three things, right? It could be greater than, less than, or equal. So we only care about the greater than. Switching to equal, greater than, switching to the next adjacent pair to be less than, or the opposite, right? Or vice versa. And one of the longest subarray of that, of alternating sequences between the comparisons. So these alternating comparisons could be formed contiguous blocks. So obviously we don't know which one's the longest unless we actually find them all and keep track of it. So when the last two elements are being compared, a sequence is alternating, such as these two. The sequence is not alternating, it's increasing rapidly, so that means we can only take a maximum of 2. Or if there's only one element, then we will take 1. So let's develop an algorithm that actually scans the array from left to right, from start to end, and then at the end of all the elements, or the last elements, or if it stops alternating, then we can just record the length of that subsequence as our candidate answer, and set the start. Basically, set the start at a new block, right? At a new element, at the new start. For instance, start at index 0. Find the large alternating sequence. Keep that. Start at index 2. Keep that. Start at index 3. Keep that. And we just update it. So this is going to be kind of like it's going to be a sliding window type algorithm, and because we're looking at two things in between. So let's have our let's see. Let's start off with our starting of the block. We can call it our anchor, our starting point, which is we're going to increment it each time. So we're going to call that an anchor. And it's going to be equal to 0. We're going to start at index 0. And then, let's see. We want to find the output. Define the output, which is going to be at minimum 1. And we also want to find whether it's larger or less than or equal to. So we're going to develop a flag, and it's going to tell us if it's -1, that means that it's less than. If it's 1, then it's greater than, and if it's 0, it's equal, right? A flag. So we're going to make it equal to begin with. Our anchoring or starting point, our output of 1, our flag. So we've got pretty much everything to start now, and also I might as well just develop n, which is the length of the array list, make it easier for us. Alright, so for let's see, call this starting anchor is better, start. So for the n of in range of 1 to n, we are going to loop through if the array at the end is greater than, we call this for I in range, for each index in I, if the array is greater than the array at index I minus 1, if the flag is equal to -1 or flag is equal to 0, right? If the flag is basically less than or greater than, I should say, or if the two numbers are equal from before, from the previous, then we're going to change that flag. So we're going to change it to 1. And then we're going to keep track of our output. It's going to be the max between our output that we have currently and the index minus our starting anchor plus 1. Else, we're gonna increment our starting anchor to be n minus 1. All right. Okay, we have to estimate. Now, next thing we want to do is else if the array at the index I is less than the array at the I minus 1, what we want to do is if the flag is equal to 1 or the flag is equal to 0, we're going to do the flag to be negative this time, and then we're going to find the max length of pretty much the same thing. I'm just going to copy this and update our flag. Else start will be and I minus. And then another else statement here. Else if the array at index I is equal to array at I minus 1, we are going to change the flag to 0, and then start equals I. So we're done. Well, we can't, it's not going to add to our return output. Okay, let's run this. Accepted, awesome. So what we did is basically we defined a couple parameters here. So we looped through the entire array itself, array length of the array, and then we basically found, we compared, is the array at I greater than I minus 1, right? Because we start off basically, the reason why we do I minus 1 instead of the I plus 1 type of index here is because we actually start out, we already have 1 in the system, right? So we don't want to, we're checking backwards essentially. And then we want to find if the flag is negative, that means that's, let's call it greater than or equal to 0. Then if it is, we'll change it to greater than. Right, we just find the output if that's, and then we find the max length of that. Else we just rearrange start and start a different number. Then we find if it's less, do the same thing, right? And then we find it's equal, they just increment, change the flag, and then make start equal to I. And therefore we're pretty much, that's how it goes. Time complexity, we have a for loop here. So it's big O n, where n is length, the size of the array. Space complexity, returning everything inside a single variable, so it's a constant space. Alright, that's it. Have a great day, guys.